Welcome to my channel Phi Concepts CHM. This is the fifth part of the band theory of solids, where we are going to derive the number of possible wave functions in a band. Number of possible wave functions in a band. Assume L as the length of the crystal. The wave function psi is assumed to be periodic in L. So, psi of x is equal to psi of x plus L, equation 1. We will write down the block solution. Psi of x is equal to uk of x into e raised to ikx. This is equation number 2. Hence, now you can write down psi of x plus L as uk of x plus L into e raised to ik into x plus L, equation 3. From equation 1, we can equate equation 2 and 3. So that will be uk of x into e raised to ikx is equal to uk of x plus L into e raised to ik into x plus L. As psi of x is equal to psi of x plus L, we can also say the same thing for the function uk. uk of x is equal to uk of x plus L. So both will cancel out. So what remains is e raised to ikx is equal to e raised to ik into x plus L. Splitting these powers into e raised to ikx into e raised to ikl. Then e raised to ikx and e raised to ikx on both sides will cancel out. Therefore, e raised to ikl is equal to 1. That is, cos kl is 1. This we get from this formula that e raised to ikl is cos kl plus I sin kl. So, cos kl will be equal to 1 for all the values of kl is equal to 2 and pi, where n is plus minus 1 plus minus 2 so on. So, cos kl for the values of 2 and pi will be equal to 1 and sin kl for the values of 2 and pi will be 0. Hence, this formula will become cos kl is equal to 1. From this equation, n is equal to kl upon 2 pi. The number of wave functions in an interval dk is, differentiate this equation as dn is equal to L upon 2 pi into dk. Therefore, the total number of possible states n in a band is, we will have to integrate dn. So, n is equal to integration of dn. Substituting dn that we have got just now, we write L upon 2 pi into integration of dk with limits minus pi by a to plus pi by a. That is, we are considering the first Brillouin zone between minus pi by a and plus pi by a. Integration of dk can be written as k with the limits minus pi by a to plus pi by a. Substituting these limits, we get L by 2 pi into pi by a minus of minus pi by a. So, next step is L by 2 pi into 2 pi by A. 2 pi will get cancelled out and we get L by A. So now so we can write down this L as is equal to N into A. Now as B tends to 0, the length of the crystal can be written as N into A plus B. So B is tending to 0, hence this can be written as L is equal to capital N into A, where N is the number of unit cells. So L is equal to capital N into A, and here we have got this L as small n into A. So NA is equal to NA. Hence from this we get that the total number of possible states in a band small n is equal to the number of unit cells denoted by capital N. From the Pauli's exclusion principle, each state can have only 2 electrons. So, the number of electrons in a band will be equal to 2 into capital N. Thank you for watching this video.